Penuh kesungguhan Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, bermisi kita
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Hujung siaran ini pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum dan salam sejahtera. Selamat petang semua. Salam Madani, salam Malaysia Madani dan selamat datang ke Pusat Tuisyen Online Percuma Akademi Youtuber. Bermula percuma di selamanya percuma. Okey, jadi kita mulakan kelas pada malam ini seperti biasa. Sebelum itu saya perkenalkan diri dahulu. Saya Cikgu Hasnitah binti Andi Mario ataupun dikenali sebagai Cikgu Hasnitah, kini berkhidmat di SMK Bagan Jaya, Butterworth, Pulau Pinang. Okay, jadi insyaAllah pada malam ini kita akan teruskan dengan satu lagi tajuk bab 6 tingkatan 4 iaitu tajuk yang kedua untuk DLP, tajuknya 6.2 Total Internal Reflection. Cik Ain kata suara saya tersekat-sekat. Okey. Bagaimana dengan yang lain, dapat dengar cikgu dengan jelas ke? Okey. Okey, jadi sebelum kita bermula, ayo kita mulakan kelas pada malam ini dengan ulum kitab Al-Fatihah. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Jadi mudah-mudahan kelas kita pada malam ini mendapat berkat daripada Allah Subhanahu Wa Taala. Okey, Cik Ain, bagaimana, masih tersekat lagi ke suara cikgu atau dah okey? Yang lain pun boleh respon sama pada live chat, okey? Okey anak-anak, sebelum kita bermula, sekali lagi cikgu ingin maklumkan kepada anda pautan kepada bahan yang cikgu kongsi pada petang ini anda boleh dapatkan pada pin message di sana. Boleh klik pada link yang tertera pada skrin sekarang. Anda bolehlah muat turun dan cetak secara percuma bahan yang cikgu kongsikan pada malam ini. Yang ini adalah untuk student copy. So untuk jawapan penuh, anda boleh ikuti kelas ini daripada mula sampai akhir. Kalau anda juga boleh cetak kemudian, tonton dulu kelas pada malam ini dan cetak kemudian bahan berkenaan. Okay, selain daripada pautan pada pin message, anda juga boleh dapatkan pautan ini pada bahagian deskripsi video di bawah. Jadi cikgu berharap bahan ini membantu anda untuk ulang kaji tajuk ini bersama-sama dengan cikgu pada malam ini. Okey, tak mengapa Cik Aing, mudah nanti harapnya lancarlah hingga ke bila kita sudah bermula. Alright, okay. So student, if you are ready to go, let us focus now. Let us begin with our lesson on 6.2 Total Internal Reflection. Okay, Total Internal Reflection. Okay, sekarang boleh dengar ke Cik Aing? Okey, sebelum kita mula, sekali lagi untuk minggu ini kita ada 2 kelas untuk subjek fizik. Yang pertama telah disampaikan pada Jumaat yang lepas. Okey, dah okey, alhamdulillah. Pada Jumaat yang lepas telah disampaikan oleh Cikgu Rosemawati iaitu skor A+ SPM bagi tajuk elektrik. Jadi siapa yang telah lepaskan kelas ini jangan risau, anda boleh tonton semula ulangannya di channel Cikgu Rosemawati dan juga channel Teacher Slinda Nordin. Jadi untuk malam ini, untuk kelas tingkatan 4, cikgu akan sambung. Kalau minggu lepas kita belajar 6.1 refraction of light. So ini adalah sambungan dia 6.2 total internal reflection. Okay. Ini adalah ahli panitia fizik di Akademi Youtuber yang telah banyak membantu cikgu untuk menjalankan kelas tuition online percuma di Akademi Youtuber ini. Selain itu, mereka juga banyak menghasilkan video-video PDPC sama ada untuk kelas DLP ataupun kelas bukan DLP. Jadi di mana nak dapatkan video-video PDPC ini, anda boleh layari portal Akademi Youtuber di www.academyyoutuber.com ataupun boleh juga muat turun di Android anda aplikasi Akademi Youtuber. Dalam apps ini kita ada setakat ini ada lebih daripada 26,000 video PDPC daripada peringkat prasekolah sehinggalah ke pra-universiti di seluruh Malaysia. Jadi harapan kami, video-video yang telah kami bangunkan ini dapat membantu anda, guru-guru dan murid-murid di luar sana. Selain itu, anda juga boleh akses kepada video ini di bahagian ruangan ilmu pada portal Delima. Okay. Okay, itu sedikit pengenalan. So, as this evening, students, let us take a look first at this situation. Okay, Ciaying boleh bagi tahu cikgu tak? Gambar apa yang Ciaying boleh lihat pada skrin sekarang? Or any other students, you can give me response. What caused the diamond to sparkle? Di sana ada permata, batu permata cantik kan? Bersinar-sinar, berkilauan. So apa yang anda lihat ada kaitan dengan apa yang kita nak belajar malam ini. What causes the diamond to sparkle? Okay. So the reason that causes diamond to sparkle will be closely relates to our topics this evening. Okay. So student, in this lesson 6.2 tutorial internal reflection, we have 4 learning standards. So the first one is to describe critical angle and total internal reflection. So joristic, we have joristic, reflection of light. It is actually more than reflection joris, okay, total internal reflection. Alright, okay. Okay, students, so let us begin with this simple activity. I believe maybe some of you have conducted this school in your school with your teachers. As for me, we will conduct this school after the exam, now focusing to finish the syllabus before the incoming exam started on October 1st. Okay, so in this activity, we are going to observe the phenomenon of total internal reflection and yet to determine the critical angle of glass. So if you look at this diagram, students, there is a ray box, okay, which is incident to this glass block at this angle. Okay, as you can see, I is the angle of incidence. Okay, and what happened, you can see there is a refracted ray. Okay, so the instruction, I think you can read later on from number 1 to number 8 how we conduct these activities. And this is the outcomes. Okay, the outcomes from the first activity. We adjust the angle of the ray box at 10, 20, 30, 40 until 60 degrees. So this is the angle of incidence. And finally, we find out the angle of refraction, okay, will also increases from 13, okay, to the maximum angle it can reach, 90 degree. And then after that, you will see that when the angle of incidence is 50 degree, there is no more refraction, but will be replaced with total internal reflection. All right. Okay. So this is a video showing this activity, so you can give a few seconds to observe them, right? So this is our setup that we mark a certain angle with a protractor. 0 angle is here. Then we begin with 10 degree. So you can see this is the refracted angle when it comes to the air. So as we learn in 6.1, when the light ray from the glass block emit to the air, it will be refracted away from normal, from high optical density. We keep increasing the angle of incidence. You can see the angle of refraction also increases. Okay, now what happened here, we increase the angle to 40 degree and the angle of incidence is recorded as 74. And right here, students, okay, right here at this moment, when the angle of incidence is now greater, okay, greater than 42 degree, you can see there is no more refracted ray, but it will be reflected internally back to the glass block. So this is what we call as a total internal reflection. Reflection in the glass block, right? Okay. And what happened if we keep increasing the angle of incidence now to 50, the angle of reflection also become 50 degree. And when we increase to 60, okay, now this angle also become wider, equal to 60 degree. All right. Okay, so this is our first activity to understand that actually total internal reflection begin from refraction of light. All right. Okay, so this is the discussion for this activity. First, what is a critical angle, students? So critical angle defined as an angle of incidence in the medium of high optical density when the angle of refraction in the medium of lower optical density is equal to 90 degree. Okay, now you can see in this diagram. Okay, so this is our light ray travel from a high optical density medium to a low optical density medium, from glass to air. This is our angle of incidence in glass, and this is our angle of refraction in air. So students, when we keep increasing the angle of incidence, so you will see the angle of refraction also increases until it reaches the border of the medium between the glass and the air. This is the maximum angle of refraction that can be reached. And for glass, angle of refraction is 90 degree when the angle of incidence is 42 degree, which means 42 degree is the critical angle of the glass block. Okay, this is the GIF showing to you what happened when we increase the angle of incidence. Okay, so initially, refraction occur. Okay, where then we increase the angle of incidence. Okay, now you can see the angle of refraction is at 90 degree. Okay, so this is where our angle of incidence is the critical angle. And what happened if we keep increasing the angle of incidence, which is greater than C? So you will see total internal reflection will occur. Okay, so for the third question, what happened to the light ray traveling through the glass block when the angle of incidence is smaller? Okay, as you can see, the first situation directed away from normal as it traveling from a medium of high optical density to a medium of low optical density. Okay, then second question, the angle of incidence is now larger, greater than the critical angle. So you will see that when I greater than C, what happened? The light ray will experience total internal reflection, which means it will be reflected back inside the glass block. Okay, so our second terms is total internal reflection. So what is total internal reflection? It is a phenomenon, okay, where light travel from a medium of high optical density to a medium of low optical density with the angle of incidence greater than the critical angle. Okay, again, total internal reflection is a phenomenon occur when a light travels from a high optical density medium to a low optical density medium. For example, the light ray travel from glass to air, okay, at an angle of incidence greater than the critical angle. Okay, so that is the two terms you must know for the first learning standard. What is critical angle and what is total internal reflection. Okay, so as a conclusion for the first activity, this is what we understand. When I less than C, the light ray will be refracted away from normal. Okay, and then later, when I equal to C, what happened? The light ray will be refracted along the glass A boundary, okay, at 90 degree, okay, as you can see in this animation. All right, and then now students, what happened when I greater than C? Okay, see here, when I greater than C, no more refraction, but total internal reflection will takes place. Okay, so I hope you are clear with the first learning standard. What is total internal reflection and critical angle? It must obey these two conditions. Okay, the first condition, the light ray must travel from a medium of high optical density to a medium of low optical density. For example, the light must travel from water to the air. The light must travel from glass into the air, for example. Second, I must be greater than C. Total internal reflection only occur when I greater than C. Angle of incidence greater than the critical angle of the high optical density medium. Okay. Okay, student. So that is for the first learning standard. Now let us test your understanding for the first learning standard by answering these questions. Okay, so you can write your response in the live chat. Okay, the first question, you are given diagram 11. It shows the fish, okay, with its image in an aquarium. All right. So this situation explained through which phenomenon? Okay. How does the image of the fish appear? Okay, as shown in this diagram, it appear on the water surface. So the phenomenon is, yes, very good. It is due to total internal reflection. A. Okay, what about the second question? Which is the correct drawing shows to you total internal reflection. Okay, remember, total internal reflection only occur when the light ray travels from a high optical density medium to a low optical density medium. Okay. Does A show total internal reflection? No, A shows reflection of light on a plane mirror, reflection of light. What about B? B, yeah, the light travel from high optical density medium to air, but this is shows refraction of light. Yes, okay. D also shows refraction of light. Okay, the light traveled from air into the glass block and then went back to air. So which one shows total internal reflection? It is C. Okay, when the light ray travel through the prism towards the air, so here where the angle of incidence greater than the critical angle, so it will be undergoes total internal reflection. So answer for second question is C. All right. Okay. So now let us take a look at the third question. Okay, you are given this diagram. It shows light ray P from given student. The critical angle for this glass block is 42 degree. Okay, so in which direction will the light ray emerge from point Q? So if you look at this diagram, the dashed line is the normal line, a line which is 90 degree to the boundary of glass block NA. Okay, so this is the angle of incidence. Okay, this is the angle of incidence 42, which is exactly equal to the critical angle of the glass block. So our situation here involve I equal to C. So what happened when I equal to C? What happened when angle of incidence equal to the critical angle? In which direction the light ray will emerge from point Q? Is it to A, to B, to C, or to D? Which one? So here we understand when I equal to C, the angle of refraction will be maximum at 90 degree, which means the light will travel through the boundary of air and glass block. Okay, if here is 43 degree, where I greater than C, then it will go to D, where total internal reflection occur. All right. Okay, and the next question, student, for the first content learning standard. Okay, here we have A, B, C, and D involve two medium, colored liquid and air. All right. So, which of diagram below shows total internal reflection where the critical angle of the color liquid is 48 degree? Okay, which one? Okay, remember the two conditions for total internal reflection to occur. I must be greater than C. And second condition, the light must travel from high optical density medium to a low optical density medium. Okay, so is it A? Okay, A you can reject. Why? Because for A, our light travel from air into liquid. So this is wrong. B also you can reject because the light travel from A, low optical density medium, to the liquid, high optical density medium. Okay, so the answer either C or D. So which one? Okay, so the first condition, travel from liquid to air, both obey the first condition. Second condition, the angle of incidence must be greater than 48 degrees. So which one? So definitely the answer is donkey. Okay, the light travel from color liquid to air with an angle of incidence 50 degree. Okay, good. Okay, settle with the first learning standard. We have done what is critical angle and what is total internal reflection. Okay, so now let us move to the second learning standard on how to relate. Okay, how to relate critical angle with refractive index. Student, you've learned refractive index before in 6.1. Okay, so we can relate them through this formula of n equal to the reciprocal of sine C. Okay, where n is the refractive index and sine C is the sine of the critical angle. Okay, so let's take a look at the second activity. Okay, this is the diagram related to this activity to discuss the relationship between critical angle C and refractive index N. Okay, so in 6.1, we've learned about Snell's law. Okay, Snell's law say that refractive index N is the ratio. Okay, it's the ratio of sine I to sine R. Okay, when to apply this law, okay, I must be always in a low optical density medium in this situation, means the air, and R must be always in a high optical density medium, which is glass. Okay, if according to this diagram. And here, student, to find the refractive index of this glass, or to apply this equation, according to this diagram, we must apply the principle of reversibility of light. Okay, so we reverse the direction of this arrow. So we make it travel from the air into the glass, which means now this R is our I. Okay, now this is become our angle of incidence, and C here is our angle of refraction. Okay, so sine R is sine C. Okay, so this is the equation. Sine 90 equals to 1. So that's why we get n equal to 1 over sine C. Okay, I hope you're clear with this. So there is a footnote there. The higher the refractive index of a medium, the smaller the critical angle of the medium. Okay. Okay, this is a table shows to you a few example of medium together with their refractive index. Okay, vacuum and air with the least refractive index of 1.0, and water 1.33. We have diamond 2.42 there, germanium 4.05. So what do we understand here? Each medium has their different refractive index. Okay, and students, this refractive index is actually described, okay, the degree to which the light ray are refract or bend as they pass from one medium to another. So the greater the refractive index mean the greater the bending effect, or the more the light refracted in that medium. Okay, now let us test our understanding on the second learning standard, how to apply n equal to reciprocal of sine C. Okay, your given diagram 6, we have A and medium P. Okay, in this diagram, there is a light ray traveling from air into medium P. And they give you two angles there. First angle 45 degree at here. Second angle 122 degree from the boundary to this refracted ray. Okay, so the question is, what is the refractive index of medium P? Okay, can you find refractive index of medium P? Okay, student, before that, you must know what is the angle of incidence, what is the angle of refraction. Okay, so we can apply this formula, n equal to sine I divide sine R. Okay, so where is our angle of incidence? Our angle of incidence lies here. So this is I. Okay, this is I, and this is our angle of refraction, R. So what is I? 45 degree. Okay, I here 45 degree. Since here is 45 degree, so I also 45 degree. And down here, how to find sine R? 122 minus 90 degree. Here is 90 degree. So we minus. So we get 32 degree for R. So you press your calculator. So it will give us the refractive index for medium P is 1.33. So from here we understand medium P probably is water with refractive index 1.33. So answer is donkey. Okay. Okay, next question, student. Okay, you are given this diagram. It shows a light travel from air entering a transparent glass block. Okay, they give you two angles there, 38 degree and 48 degree. Again, find the refractive index of the glass block. Okay, how to find refractive index of the glass block? So we apply Snell's law formula, n equal to sine I divide sine R. So where is our angle of incidence? Is it 38 degree? Okay, this one you have to be careful. Our angle of incidence is here. So it is 90 minus 38 degree. And this is our angle of refraction. So it is 90 minus 48 degree. So I is 52 and R is 42. Okay, so answer 1.18. Okay, the refractive index of the glass block is 1.18. So answer is boy. Okay, are you doing good so far with this question? If you follow me, you can type number 1 in the live chat. Okay, if you have any question, also you can type there. I will please to assist you. Okay, students, next question. Okay, next question. We have diagram 12. Okay, tengok Raja 12. It shows a path of light ray pass through two mediums, okay, of refractive index N1 and N2. So this is our first medium with refractive index N1, and this is our second medium with refractive index of N2. Okay, so the question is, which of the following will produce total internal reflection? Keadaan mana yang akan menghasilkan pantulan dalam penuh? Okay, which one? Is it A, I increased and then N1 greater than N2? Okay, or B, I decreased and then N1 greater than N2. Or C, I increased and then N1 greater than N2. Or D, I increased and then N1 greater than N2. So to answer this, you can go back to the two conditions that must be obeyed for total internal reflection to occur. So what is the first condition? The first condition, the light must travel from high optical density to low optical density medium. Okay, so now you can see this is our incident ray. So this incident ray must be in a high optical density medium. So N1 must be greater than N2. That is the first condition. So you can see which one, N1 greater than N2. A is correct, B is correct. So C and D, you can say bye-bye. Okay. Second condition, I must be greater than C. Okay, I must be greater than the critic. So we must increase I, because now when I at this condition, the angle of refraction is exactly at 90 degree. So I is the critical angle. So to let total internal reflection to occur, I must be increases. So it is greater than the critical angle. So answer is A. Okay, the answer is A. Okay. Okay, next question, diagram 9, students. Okay, we have light travel from air into water. Okay, this is the normal line between, this is glass. Okay, the first medium is glass. Okay, stated there, the first medium is glass, second medium is water. So we have light ray traveling from glass into water. Okay, this is the normal line. Okay, so the question is, what can possible happen to the light ray in a water if the refractive index of the glass is bigger than that of the water? So now they give us refractive index of glass is bigger than water, which means glass has higher optical density compared to water. So now the light travel from high optical density to low optical density medium. So it must be refract away from normal. So number 1 you can reject. So number 1 is wrong. So number 2 is correct, refract away from normal. And there is a possibility it can experience total internal reflection when I here greater than C. Okay, so answer should be number 2 and number 3, which is C. Okay. Okay, so that's for the first two learning standard. So I hope you are doing well with them. So after this short break, we will continue with the third learning standard. So don't go away. I will be back very soon. Okay. Okay, welcome back to our lesson. This is tuition online percuma brought to you by Akademi Youtuber Malaysia with the collaboration of Kelab Guru Malaysia and EDD Malaysia. Bermula percuma, selamanya percuma. I'm Cikgu Hasnitah from SMK Bagan Jaya, your presenter tonight. We are now discussing Form 4 topic 6.2 Total Internal Reflection. So we have done with the first two learning standard, what is critical angle, what is total internal reflection, and then we have looked what is the relation between C and N, what is the relationship between critical angle C and the refractive index N. They can be related through the formula of N equal to reciprocal of sine C. Okay, and now for the third learning standard, let us continue with how to communicate. Okay, example of natural phenomena and applications of total internal reflection in our daily life. Okay, before that, student, again, for those who just joined us, you can find or you can get the module, PDF module for this lesson provided in the pin message or in the video description below. So you can click on them, download and print them out all for free. Percuma saja anda boleh muat turun, cetak, keluar dan gunakan bersama-sama dengan video ini sebagai bahan tambahan untuk ulang kaji anda. Okey, cikgu harap bahan yang cikgu sediakan ini membantu anda untuk faham tajuk ini dengan lebih baik. Alright, so without further ado, let us continue with the first example of natural phenomenon relates to total internal reflection. Okay, here you can see two phenomenon. First one is the formation of rainbow, which is actually combine a few light phenomenon. Okay, and second we have a mirage. Okay, so how does rainbow form? So there are four sequence to describe the formation of rainbow. So students, as you can see in this diagram, which also available in your textbook, and this is the GIF, shows to you what happened when light ray entering a raindrops. Okay. So the formation of rainbow started from when light from the sun enter the water droplets. So what happened? The light ray inside the water droplet will refract, okay, and disperse into different colors. So two light phenomena will occur first, refraction of light and then dispersion. The white light will be dispersed into 7 different colors. And then later what happened when all these different colors hit the back part of the back water drop, what happened? Total internal reflection will occur, okay, on the inner surface of the water droplet. Okay, this is happen when the angle of incidence at the back part of the water droplet is greater than the critical angle of the water droplet. Okay, then what happened later? This light will be reflected. Okay, the reflected ray will experience refraction and dispersion again. Okay, when they leave the water droplets. Okay, and finally, you will see rainbows as 7 different colors. Okay, starting from red, ended with violet, purple. Okay, so I hope you're clear with the formation of rainbow. Started with refraction and dispersion, and then total internal reflection, again reflection, refracted, okay, refraction and dispersion, and finally 7 colors appear as rainbow. Okay. Okay, the second phenomenon, okay, the second natural phenomenon involving total internal reflection is a mirage. Okay, what is mirage? Mirage is the formation of image of a sky or of a cloud on surface of a road in a sunny day. Okay, so how does mirage occur? You can see the diagram here, number 1, number 2, number 3. So what happened at point 1? Okay, what happened here, students? The layer of air above the road is hotter. In a hot sunny day, okay, the layer of air above the road surface is hotter compared to the uh, air at the upper layer. Above here, the air is colder. Okay, so what happened here? Light ray travel from cold air into hot air. Okay, the light travel from cold air into hot air. So what happened when light travel from cold air into hot air? Mean it travel from denser to a less dense medium. So what happened? It will be refract away from normal. Okay, and as they refract from one layer to another downwards, the angle of incidence will keep increasing. Okay, and at a point when the angle of incidence is greater than the critical angle of the air, so what happened? Total internal reflection will occur. Okay, at the third point, total internal reflection occurs, so the light ray will be refracted into the eyes of the observer, so they will see the image of the cloud appear as a puddle of water on the road surface. Okay, so the sequence from number one, when the light ray travels through air of different density, from high density to low density, it will refract away from normal, and as I is keep increasing, finally when I greater than C, total internal reflection occur, and the observer seen the image of the cloud as a puddle of water on the road surface. So when you go closer, it's gone because it's not really there. Only the image of the sky or the cloud above. Okay, due to total internal reflection. So that goes with formation of rainbow and mirage. Okay, now let us take a look at a few applications of total internal reflection in our daily life. Okay, first, in a prism periscope. Okay, student, what is prism periscope used for? Prism periscope used to see an object behind a barrier. You can also find it in an submarine. Okay, to see the things above. Okay, it is made up of two right angle prism as shown here. ABC is the first prism on top, and second we have DEF, the second prism below. Okay, and this is the object. Okay, this is the object, and this is where the observer's eye. Okay, so what happens to then a light ray from an object, as you can see here, travel along the normal to the side AB. Okay, this is side AB. The light enter at this point normal. Okay, along the normal with side AB, 90 degree to side AB. Okay, then what happened? The light ray will reach side AC. Okay, as they travel towards travel in a normal line. So once they enter the prism here, it will continue travel in a straight line until they reach side AC. So what happened after they reach side AC, students? Okay, when they reach side AC, the angle of incidence here is 45 degree. Okay, the angle of incidence here is 45 degree, which is greater than critical angle of the prism, which is 42. So by this, we understand total internal reflection will occur. So now the light travel downwards. Okay, entering the second prism. Okay, so here again, another total internal reflection occur as I here 45, again greater than the critical angle. So it will undergo total internal reflection as shown in this diagram, and this light ray will be entering the eyes of the observer, and it will see the image as this characteristic shown by in this diagram. Okay. Okay, this one the explanation in what happened in the E and F. Okay, so the image form will be upright and same size as the objects. This is the characteristic of image form. All right. Okay. Now, second application we can see in optical fiber. Okay, optical fiber used a lot in medical and telecommunication field. Okay, so this is the structure of optical fiber, consists of outer cladding and inner core. The inner core has a high refractive index, while the outer cladding has a low refractive index. Why? So that total internal reflection can occur inside. Okay, so first, the purpose, the users widely used in field of telecommunication and medicine, as I mentioned just now. So normally, student optical fiber is made from pure glass or plastic fiber with a very high refractive index. Okay, so easy for total internal reflection to occur inside. Okay, then the inner core, high refractive index, surrounded by layer of cladding, which is called the outer, with a low refractive index. Okay, and what happened? Light signals will enter one end of the optical fiber, and inside it will experience continuous total internal reflection until it reach the other end. Okay, so what is the advantages of using optical fiber in telecommunication and in medicine? For example, in endoscope, the signal can be sent rapidly without disturbance from electric signal. So we can send the signal in a very short period. Okay. Then the third application is in a cat eye reflector. You can see this on the road surface, student. So what happened? How the cat eye reflector can emit light. So actually, inside the structure of the cat eye reflector will let total internal reflection occur. Okay, so when the light ray from the car enter the reflector, okay, inside total internal reflection occur, so it will emit back the light at the other side of the reflector. Okay, so what is the purpose of cat eye reflector? It is for safety, especially at a dark condition at night, okay, for all the road users. So this is how it works. Light ray from the car headlight enter the reflector, experience total internal reflection on the back surface of the reflector. Okay. And the fourth application, we can see in a colored water stream, or normally we call it as a fountain, water fountain. Okay. Beautiful, right? Okay, so students, what happened here? A laser beam, okay, which enter the water stream, experience continuous total internal reflection until it comes out, okay, from the end of the water. So it appears as a colorful water show. Okay, so this one you can try at home. You can find a plastic bottle. You can poke one hole as shown in this diagram, and you can point a laser beam in the same level with the hole. So that when you fill up with water and you open the hole, you can see that the light will be undergo continuous total internal reflection along the water stream. Okay. Okay, that is for the application. 2 example of natural phenomenon and 4 applications in our daily life. Okay, now we have come, I think, to the peak of the content, the most important part, how to solve a problem involving total internal reflection. So, jom kita cuba selesaikan soalan ini bersama-sama. Kalau anda faham pantulan dalam penuh, sepatutnya tiada masalah untuk selesaikan soalan ini. Okay, so the first question, you are given 2 diagram, 2.1 and 2.2. It shows a light ray path entering a glass prism. So both light travel from A, entering glass prism, but at different angle. Okay, and given the refractive index of the glass prism is 1.5, student. Okay, so based on diagram 2.1, here you have to find angle theta. So how can we find angle theta? So what do you see here, student? This is the light at this prism. So this is the angle theta, and the refracted ray is exactly at the boundary of the glass prism in air. So we understand here when R equal 90 degree. Theta is actually our critical angle. Okay, so how to find critical angle when you are given refractive index of 1.5? Macam mana cari sudut kritikal bila diberi indeks biasan 1.5? So apa formula dia? So we apply this formula. N equal the reciprocal of sin C. N equal to 1 over sin C. So N is 1.5. So now we can find C. Okay, so you press your calculator, find epsilon, answer 41.81 degree. Okay, for this answer, you please don't round off to 42. Okay, leave it as 41.81 degree. Okay. So the first mark is here for the substitution. Second mark is for the answer 41.81. Don't forget the degree there. Okay. Second question. In diagram 2.2, you have to complete the light ray path from point O. Okay, now this is the incident ray. It is traveling at the normal. Okay, it is traveling at the normal. Okay, between the A and prism. So you have to find, before you complete this drawing, you must know what is the angle of incidence here, students. So what is the angle of incidence here? Okay. So how to find I? This is 45. This is 90 degree, which means this is also 45 degree. So our angle of incidence is 45 degree, which is greater than the critical angle of the glass block, 41.1, 41.8. So we understand here in 2.2, total internal reflection occur. So by that, how to draw? We draw the light ray at this direction. We angle of here 45 degree, here also 45 degree, the angle of reflection. Okay, so I hope you are clear with this. And second, what is the light phenomenon occur in diagram 2.2? It is total internal reflection. Okay. Okay, next question. Okay, now diagram 2.3, it shows the cross section of a simple periscope. Okay, but you see the prisms are missing. So you have to complete the diagram by drawing the position of the prism and then later to draw the ray of the path of the light ray that entering both prism. Okay, so how to draw the prism? First and foremost, you must draw the position of the prism correctly. So 3 marks. This is your first mark. Draw correct position of prism, the first mark. Second position, when you draw total internal reflection, occur twice. Okay, on the first prism up here and on the second prism down here. And third mark, when you draw and label your diagram. So how we construct our ray diagram? So this is how we place the prism on top at this position. So we draw 2 light ray from the object. Okay, please don't forget the arrow as well. So here, total internal reflection occurs. So the light ray move downwards. So this is the position of the second prism. Another total internal reflection occur here. And finally, this is the image form. Okay, at the eyes of the observer, it is upright and has same size with the object. Okay, so the most important thing when you draw, don't forget your arrow. This one, you draw the arrow. Okay, draw the arrow. This one also draw the arrow. Down here, the arrow. Another arrow here. And another arrow here. Okay. Okay, next student, next question. Okay, now we check on this. Okay, in this question, you are given table 2. We have 3 types of prism, PQR. The first aspect is the refractive index, 1.52 for P, 1.46 for Q, and 1.43 for R. Okay, and the size of the prism, P and R has a big size, is a big prism, while Q is a small prism. Okay, student, in here, you are asked to, this prism will be about to use in a periscope. Okay, use in a periscope. So based on your observation and analysis on this table, you have to state the suitable characteristic of the prism and give a reason for your choices. So first, the refractive index. Okay, to construct a prism, what can we say about the refractive index? Must be high or must be low? Remember, the prism must have a high refractive index so that total internal reflection occur easily, where the critical angle will be smaller. So, easily for total internal reflection to occur. So, we choose a prism with high refractive index. Please don't write the number 1.52. You just say high refractive index or just say high. Okay, reason, as I mentioned, so that the prism has a small critical angle, which means total internal reflection will occur easily. Okay. Second, the size. So the size, you think logic, better to be small or better to be big. So we choose a prism with a big size, big. Okay, big size, bigger. Why? So that more light will enter the periscope, receive more light enter. So this means the image produced will be brighter. Okay, so by this, which one is the best prism? So obviously we choose P. Answer is prism P. Okay, and the next question, students, you are given diagram 1.1. It shows a light path travel from air into prism. Okay, this is the light travel given the angle here is 45 degree. Okay, so this is 45 degree, this is 90 degree. So this is a right angle prism. Okay, first question, you have to calculate the refractive angle of the light in the prism if the refractive index is 1.5. So how to find refractive angle? Okay, so how to find this question? This is the formula we apply. Okay, N equal sine I divide sine R. Okay, N equal to sine I divide sine R. Okay, how to know what is our angle of incidence? Student, first, you have to draw a normal line here. So we draw a normal line at this point. So this is 90 degree. Okay, 90 degree. So since here is 45 degree, which means our angle of incidence also 45 degree. Okay, our angle of incidence is 45 degree. So this one, sine I, sine 45. So where is our angle of refraction? So what happened to the light ray when entering the prism? It will be refracted towards normal. Okay, so it will be refracted towards normal, somewhere here towards normal. So we find that. So this is our R. Okay, this is our angle of refraction. So sine R. So we know N 1.5, we know sine R, sine 45. So by this, we can determine R 28.13. So since the light ray refracted towards normal, so the angle of refraction is smaller compared to the angle of incidence. Okay. Second, will the light ray experience total internal reflection at AB? So this is the question. Explain your answer. So what happened when the light ray reach AB? Will total internal reflection occur? So the answer is yes. Why? Because the angle of incidence is greater than the critical angle. So if you draw correctly and the light reach here, so when you calculate the angle of angle of incidence here, it will be greater than the critical angle. So total internal reflection will occur there. Okay. Okay, next. Okay, next question, students. Now we have a binoculars. Okay, binoculars is used to see distant object. For example, if you went to stadium watching for a football match, so you can bring binocular when you are sitting on a very end of the spectators bench. Okay, so this diagram shows an incomplete path of light ray, so you have to complete them. So where to begin? So you can start it from here. So how to draw? This is our prism. So what happened there? Total internal reflection occur here. Another total internal reflection occur here. So this is the third total internal reflection, and this is the fourth. So total internal reflection occur 4 times. Okay, occur 4 times. 1, 2, 3, 4. Okay, and finally the light ray emits here, entering the eyes of the observer at the eyepiece. Okay. Okay, next question. You are given the situation. State the suitable characteristic of the lens to be used as the objective lens. Okay, this is from the previous question. So the focal length of the lens, student, in binocular, the focal length of the objective lens must be longer compared to the eyepiece. So we will have a bigger magnification, where the magnification is the ratio of the focal length of the objective lens to the focal length of the eyepiece. Okay. Bigger magnification means it will produce bigger image. Okay, next, the diameter of the lens must be bigger so that more light will enter the binocular. So by this, we will produce brighter image at the end. Okay. Now the last question for this evening. Okay, this is a 10 marks essay question based on applications of total internal reflection in optical fiber. So you can see this diagram. This is the light ray entering the optical fiber, and it's a total internal reflection occur continuously inside until it reach the other end of the optical fiber. And inside we have the inner core, the outer layer is the outer cladding. Okay, so you have to design fiber optic which can work efficiently based on these 3 aspects. First, the refractive index of the outer layer and the inner core, which one should be higher, which one should be lower, and why. Second, the flexibility of the material used. And third, other characteristic of material. So for this one, student, you will find in section C, you can give more than 5 suggestion and reason. Okay, so this is the example of answers. First, we talk about the refractive index. So remember, for optical fiber, the refractive index of the outer layer must be lower than that of the inner core. Okay, or vice versa. Why? So that total internal reflection will occur inside the optical fiber. Okay. Second, the material must have a high flexibility so it can easily bend or not broken. Okay. And made from a strong material so it does not break easily. Okay, again, the characteristic of material, it made from a thin material, so the optical fiber will be light and easily used in a small area. And last but not least, you can talk about the density of the material. Okay, density of material should be low, so our optical fiber will be lighter or have low mass. Another suggestion you can ask, use a bundle optical fiber. Compared to single one, we use bundle of optical fiber so that more signal can be sent. Okay, at one time, more signal can be sent at one time. Okay, so I guess that's all for tonight with total internal reflection. Itu saja masa yang kita ada pada malam ini. Alhamdulillah kita berjaya habiskan. Cikgu harap apa yang cikgu kongsikan malam ini sedikit sebanyaklah membantu anda untuk ulang kaji dengan baik, okay? Especially for the Form 5 students. I hope this can be help you as your preparation for your incoming SPM, and also for the Form 4 student, you can use this session as a revision for your final exam, which is just around the corner. So again, thank you very much for your time. Terima kasih banyak-banyak luangkan masa bersama saya malam ini. Mudah-mudahan dapatlah faham tajuk ini dengan baik. So sesungguhnya yang baik kepada Allah, yang kurang itu daripada kekurangan dan kedangkalan ilmu saya. InsyaAllah kita jumpa lagi minggu hadapan. So I wish to see you again next week. We will continue with 6.3 image formation by lenses, dan untuk tingkatan 5 minggu depan jangan lupa bersama-sama dengan Teacher Slinda Nordin untuk pecutan SPM siri yang pertama pada hari Jumaat 9.30 malam. Jadi itu saja daripada saya. Sebelum itu cikgu kongsikan dulu link untuk sijil e-express. Anda boleh isi pautan ini. Please fill this link to get your certificate. Fill it with your name and your IC number correctly. So the cert will be sent to your email just enabling. Anda akan dapat sijil dengan pantas kerana ini adalah sijil express yang dijana oleh tim Akademi Youtuber. Terima kasih kepada Yuzuli dan Yusufi yang telah menyediakan sistem sijil e-express ini. So itu saja. Selamat berehat, selamat beristirahat. InsyaAllah kita jumpa lagi dalam kelas-kelas yang akan datang. Assalamualaikum, salam sejahtera dan bye-bye semua.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.